Hello everyone, and today we'll be speaking on true GitOps using Crossplane and Argo CD. My name is Sayam Pathak, and I'm working as Director of Technical Evangelism at Civo that provides managed Kubernetes service, which is called Civo Kubernetes. And I'm a CNCF ambassador, pretty active on Twitter, and I teach Cloud Native on YouTube as well. So you can follow me everywhere.
Hello everyone, my name is Saloni Narang. I basically work in SAP Labs as a developer, SAP Labs in Bangalore, India. And this is my Twitter profile. You can follow me here. Please note down, I have less followers right now. And this is my LinkedIn profile. Sorry for the extra numbers over here.
Okay, so we were chatting, outside, and Saloni was describing me the problem that she was facing with achieving true GitOps. But while we were having the conversation, she said that she already had a problem and she understood GitOps terminology and then implemented some of the tooling and solved some piece of the puzzle already. So Saloni, to set the context right, how about you share what problem you had and how you solved that before we jump onto the actual problem of achieving the true GitOps?
Sure, Sayam, I will do that. Before moving to my problem, I would like to share with you all what GitOps is. So, GitOps, in a very simple or layman language, it is a mechanism where Git is the single source of truth. So, a developer writes a code and commit it to Git, and then he or they can easily deploy their applications using Git. So basically, when your application is deployed, don't you think that it should be automatically deployed and the changes made by developer should be auto-applied? So once the changes is auto-deployed or the changes is reflected, now you would like to monitor your changes that is applied. And I'm sure you don't want to write a long code for monitoring whether your code is deployed, whether your application is deployed. So basically, once your application is deployed successfully, now what happens is, suppose some developer makes changes to the application, and what happens if the changes are not reflecting in the system? Suppose what happens if the changes are not desired? So basically, in drift detection in GitOps, what drift detection means is it maintains the sync between the actual and desired state. So this is how the workflow is. And now moving on to repeatable infra applications. What happens if a developer wants various applications, internal development application? And coming to the versioning and rollback, suppose a developer creates an application and wants to add new features in that application. So suppose if your application breaks in between, what will happen? Obviously, developer wants to roll back. So there is the concept of versioning in GitOps. So all in all, this was GitOps ideology, or you can say this was GitOps, how GitOps involved, what and all technologies, what and all toolings, what and all GitOps do. Now moving to my problem, Sayam. What was my problem? So what was happening is I created my application and pushed the code to the Git. Now I built the application or code using the toolings like Jenkins and GitHub Actions. Now what I did is I prepared artifact before in the previous step and pushed that artifact to the OCI registry. Now this is where I am facing my problem. So I am facing problem in the deployment of the application. So now what is happening is there are tools kubectl or helm apply, which I have to use. Then I need to manually monitor the uptime of the application. Then I need to secure the cloud credentials, and then same with the kubeconfig. And then, as I mentioned earlier, drift detection, the sync between the actual and desired state was missing, and then infra and app setup was having too many tools. Now, my problem was this IAM with respect to the deployment of my application in Kubernetes. Now, coming to the solution. What is the solution? What is the solution I used? So there are tools for this solution like Flux and Argo, but I personally used Argo for this. So what I did is I installed Argo onto my system, onto my cluster, and then this is what I did after installing Argo. So I again built my application and pushed the code to the Git, committed code to the Git, and after that built my application using Jenkins, toolings like Jenkins and GitHub Actions, and then I prepared artifact which I pushed into the OCI registry. Now this is where the difference comes in the deployment. Now Argo is pulling the changes from the Git. As soon as there is some changes in the Git repo, so what it is doing is, it is automatically applying all the changes. Moreover, it is also helping me to deploy my application. So basically Argo, as you can see, it is working on the pull mechanism. It is going to the Git and helping me out to push, to automatically apply my changes and deploy my application. So basically, you can see over here, Argo is using all the GitOps principle. I will let you know what GitOps principle is. So basically, GitOps have 4 principles, which is under GitOps initiative, Open GitOps initiative, and it is made by the working CNCF group. Now, moving on to the 4 GitOps principle. First GitOps principle is declarative. So now you would like to declare the state of your application in YAML, declaratively. You want to declare the desired state declaratively using YAML. Then coming to the version and immutable, you would like to maintain version history so that you can easily roll back. You can go back to your previous version if your cluster or system breaks. So you would like to go back, you can easily make changes and roll back to the previous version. If there is some break in the cluster or if something goes wrong in your infrastructure, you would be easily able to roll back. Now, coming to the pulled automatically, agent should pull any new changes from the source automatically. Now, coming to the 4th principle, you can continuously reconcile. So, agent keep the desired state and actual state in sync. So, this is what I discussed previously. This is drift thing. So, agent keep the desired and actual state in the sync. So, this is drift detection policy, principle of GitOps. Now, I have told you what Argo CD is. It works on GitOps principle. And now we will move on little bit onto Argo CD components. How Argo CD works, it is a workflow of Argo CD. It is a high-level architecture of Argo CD. So once you install Argo CD onto your Kubernetes cluster, so these and all components you will be able to see onto your cluster. So this is the workflow. User pushes the code to the Git. Now, repo server stores the cache. It tries to fetch the code or the data from the Git, and then there is a controller which maintains the sync between the API server and the repo server. Then there is UI. So UI keeps updating the live status of your application. Then your application is deployed successfully. So whenever you set up your, do the setup in production, so these four are the components you will be able to see. So first one is notification controller, second one is application controller, third one is repo, server cache, as I mentioned, it stores the cache, and deck server and Redis, sorry, there is no space in between, forgot to put, and Argo CD server. So this was all about the workflow. This was all about Argo CD architecture.
Cool. I think that gives a good gist of what GitOps is, where it is fitting in your particular problem, so that you are able to deploy your application from Git to the Kubernetes cluster. So that part is solved. What else do you need? You already have Argo CD, right? You are deploying your application. So what do you want more from GitOps?
Before moving, what do I want more from the GitOps? I would like to give you a summary again. What are the benefits that Argo is providing? So, multi-cluster, so you can deploy your application in multi-clusters. Then audit trails, you would be able to track the events. Then CLI for automation, drift detection, sync between the actual and desired state. Automated deployment, whenever a coder develops the application, it will be automatically deployed, and changes also will be automatically deployed. Then version control, as I mentioned, whenever you will create a new application, so and you add special features to your application, it will be version controlled. And if something breaks, you will be easily able to do rollbacks. It also offers a very nice web UI. Then single sign-on, and yes, the last one is observability. Now, Sayam, I actually want to achieve true GitOps for both infrastructure and application. And yes, I want everything. So can you help me with that?
Cool. So basically, you want to GitOpsify everything. That's interesting use case, and I think when you have the GitOps principles, when you have powerful tools like Argo CD, you should be able to leverage some of the other components from the CNCF ecosystem to achieve this particular use case. I actually have exactly this tool called Crossplane, which is open source CNCF project that can help you in achieving the solution to the problem you just mentioned. So let's discuss a bit in brief about Crossplane. So Crossplane is an infrastructure provisioning tool. Like for example, you want to provision the resources, the computes, the Kubernetes clusters, and all these things in your particular cloud vendor. You can do that via Crossplane, and it is using the Kubernetes API. Now here is the benefit and the power that it is giving. So it is natively using the Kubernetes API to actually declare your infrastructure. So it is declarative. You can declare your infrastructure in YAML, and you can do kubectl apply, which is fancy because as Kubernetes administrators, you already know the YAML files, you already know all that syntax very well. So you would be able to create declaratively your infrastructure. You can define, I need a Kubernetes cluster, I need these many resources from this cloud vendor, and you will be able to create that infrastructure. It uses the, so infra is stored in Git. Now this particular section which is there, so this thing, infra stored in Git. So since these are the YAML files, you can easily store them in Git repository. And Saloni, you already mentioned about Argo CD. It can watch the GitHub repository, and it can pick up those YAML file customization or helm and deploy onto the cluster, which is great. That's what we need. So it automatically will take all the files, all the YAML files in the infra repository or whatever you might name it, and then deploy onto the cluster. So Argo CD job finishes over there. But now Crossplane, since Crossplane is having its controller, it will and it will be configured with the provider, which I'll show you obviously in the demo. It will be able to create the infrastructure using the GitOps approach. It is extensible because because Crossplane has all the integrations with the cloud vendors like Google, AWS, GCP, DigitalOcean, Civo, like you name it, you have the Crossplane provider for that particular cloud vendor, and you can create the resources within that provider. Also, you have something that you can, since it is native Kubernetes, so you can use the other Kubernetes tooling. Like suppose you have Kyverno installed onto your cluster for managing your policies. You can apply policies for your namespaces where you are applying your Crossplane components as well. So you can use the native policies, the quota restriction, all the benefits of Kubernetes through Crossplane for managing your infrastructure. So that's what makes it fancy. Then it is less complex because it follows the same tooling. You don't have to learn any new language. It is YAML, and if you are in the Kubernetes space, in the Kubernetes ecosystem, so you would know as the Kubernetes administrators. I have something for the developers as well. Then it uses the power of controllers. So Kubernetes is main power is the controllers that it has, the control loops, the reconciliation loops. You have the deployment controller, replica set controller, like you specify, I need 3 replicas of my application. And Kubernetes will make sure that your 3 replicas of your application is always running. Similarly, Crossplane will take care of the drift detection that Saloni was mentioning for your infrastructure as well. So let's say you created a Kubernetes cluster, and after that Kubernetes cluster, somebody in your team has removed a particular node in live, and they have not committed that to the Git repository. So Crossplane will identify the actual state from Git and will make sure that your infrastructure is in sync. So even if it was deleted without any consent or without telling you, that node will automatically come up. So that's what Crossplane makes sure. The drift detection is also there. So that's what it follows the GitOps principle. Now this particular section is pretty neat feature and very important feature for the developers. So compositions is something that can be defined for multiple cloud vendors. So what exactly Crossplane is trying to solve here is, let's say you have multiple cloud vendors and everybody is talking about multi-cloud, like I want maybe S3 from AWS and cluster from somebody else and a database from Google Cloud. So all these things are there. Or maybe you have different cloud vendor integrations. You just need to have the best resource for a particular infra. So what you can do is your admins can define the composition files. These files will be the actual configuration and the specification of the cloud vendors that you want to integrate Crossplane with. And as a developer, you would only need to require, I need a database and I need from which cloud vendor the memory, nothing else. As a developer, it becomes very easy because you don't have to specify anything. So Crossplane, you can use compositions to even empower your internal developer teams so that they can create those, and that goes via git commit, PRs. Your infra admins can approve those pull requests and your infrastructure is ready. So that's what in a nutshell Crossplane is. More on its working. So you have a base Kubernetes cluster. In our case, we'll be using Civo Kubernetes. On top of that, we'll be installing Crossplane controller, so that as soon as there is a custom resource which is there for the infrastructure, it is able to identify and do something with the provider which is configured. So after installing Crossplane, we'll install the provider. So provider is basically your cloud vendor choice that you want to work with, where you actually want your infrastructure to be. And then you have the configuration. So obviously, let's talk about AWS or Civo. There are certain secret key, access keys that you need to have in order to access that particular cloud from your account. So those comes under the cloud provider specific configurations that you will be deploying, so that when Crossplane tries to create a resource, it has the proper credentials to create those resources. And then you create the custom resource. So these are the actual YAML files that your developers or admins will be committing to Git, and from here the controller will pick it up and create that resource in the configured provider. So to the problem that Saloni you just mentioned, this is what my proposed architecture would look like. So this part is familiar, so we'll quickly go through it. So you have your GitHub repository. Inside your GitHub repository, you have a couple of folders, a deploy folder where your application is living, and you have the infra folder. You can have infra as a separate repository. For this particular demo, we have the infra folder inside the same Git repository. And as soon as this happy developer pushes the code to the main branch of Git, there is a GitHub actions that gets triggered that builds the image, then pushes that image to the artifact, and also gets the SHA, the Git SHA of that commit, and change the tag in the deployment file. And Argo CD that is installed onto your Kubernetes cluster is watching this deployment folder, and as soon as there is any change in the YAML file, it will deploy that onto the cluster and give you a new version of your application that can comprise of pod, services, persistent volume, PVC, whatever stuff is there. Now there is another application that we have created here, which is Argo CD is monitoring the infra repository. So like Saloni said, she wants the internal developer teams to be empowered to create the repeatable infrastructures. So what they can do is they can just create a PR to this infra folder with the custom resource of the Kubernetes cluster or whatever resource they want to create, and then Argo CD will apply that. Argo CD doesn't know what YAML it is applying, it is just applying the YAML file. Now there is also Crossplane that is installed onto this cluster. Now as soon as their Argo CD applies that Crossplane custom resource, the controller will be watching that and will create the infra with the configured cloud provider. So that's how overall the working would look like. Let's move and see all these things in action so that I'm not faking it up. It actually works. So it's demo time. So this is Civo Kubernetes. So Civo, just I mentioned, like it's a cloud provider. So we not go much into that. We just want a Kubernetes cluster. So we'll click on launch my cluster. So there's nothing right now. You can see that, and we are just creating a new cluster, OSS Japan, and we'll just leave everything default. Choose a size that we need, and I'll just install Argo CD because we need Argo CD on to that particular cluster, and we'll click create cluster. So this will create a Kubernetes cluster in the backend. It will take a couple of minutes, so we can go to the Git repository and see actually what all stuff is there inside Git. Let me zoom in a bit. So that's how your repository structure looks like. You have a simple file, Python application Flask, and you have a Docker file to build the code, and you have the deploy folder. Your deploy folder is actually having a YAML file. A YAML file is actually having the deployment and the image and the service, all these components. Obviously, it can be a more complex application with more complex stuff inside it. Now let's go back, and you have this infra repository which has the cluster. So this is how the custom resource for Crossplane for Kubernetes, Civo Kubernetes cluster looks like. So you have a kind Civo Kubernetes. That's what the power of custom resources is. So you define the API version, Crossplane, name, and the spec section, your cluster. So this should actually create a Civo Kubernetes cluster called test Crossplane with this particular size and with these applications installed. And this is specific to Civo provider, and you can configure whatever provider you need to. So we can see our cluster is ready. So I'll click and download the kubeconfig file. Yeah, I know it's super fast. Export kubeconfig users, and we'll copy same in another tab as well because I would need that. So kubectl get nodes. So you can see your cluster is up and running. So we have that, and it should also have started to deploy Argo CD components. And you can see the Argo CD components have started to get deployed. So you can see all these are getting created in the backend, whatever Saloni just mentioned, right? In HA mode, you have notification controller, repo server, Dex, Redis, Argo CD server, application controller. So all these components are installing over there. So this is fine. What else we need to do now is we need to install Crossplane. So let's install Crossplane as well. So we'll create a namespace, Crossplane system, and we'll do a simple Helm install. I already have added the Helm repo, so I'm not going to do that again. And I'll just do Helm install of Crossplane in the Crossplane system namespace. Now, meanwhile that is happening, we can go back again to the repo to see some of the other details. So this is the GitHub actions that I was telling in the architecture diagram. So you can see it is actually using the Docker build push action. So it is building the image using the Docker file which is present in the repository, and then pushing it to my Docker Hub account, getting the git SHA and generating the deployment. So what it is doing is, when I showed you the deployment file, it is changing the image tag with the latest version with respect to the git commit that happened to this main branch. So that is what it is doing is. So I have a Jinja template for that. So you can see in the templates, and in this section you can see the image deploy tag is the variables. So that is something, as soon as there is a commit, there will be a new SHA tag with respect to the commit. It will attach the CAD, the GitHub action will attach this particular hash and will be committing that to the deploy folder hello.yaml file. So that's on a high level that it is doing. Okay, now we already have this installed. Let's do kubectl get pods -n Crossplane system. So our Crossplane is running. So what next we have to do is I told you we need to install the provider. So we'll install Civo provider because we need to create the infrastructure from Civo. So we'll install that provider. Provider is created, and after that we have to install a secret, because I told you after installing the provider, you need to configure that with the secrets. So I'm not going to show you the secret key. This credential is fake. So I already have a credential, but the files look exactly the same. And provider config means it will use this credential that will be created above, and it will be using the region as FRA, means in the Frankfurt region, whatever will be created in the Frankfurt region. So I have that file. Let me apply that. I think it is provider. Okay. Also, meanwhile, I need to open some firewall ports. So I'll do that now. For now, I'll just open it. Don't judge me on this. Cool. So our provider is also there. The secret and the Civo provider is created. Awesome. So we can actually now kubectl get. I can go back and we can actually see the Argo CD. Everything should be up and running. We'll quickly open Argo CD now. Cool. All components are running. We'll port forward that. And we'll get the credentials for this particular Argo CD and proceed. So this is how the Argo CD look like. I mean, let me log in. So that's how the Argo CD UI looks like. So let's first create the application, what Saloni has already done. So we'll do the app side of things, and we'll sync policy is automatic, means as soon as there is any new change, it will automatically sync. Auto create namespace, it will do that. Repository URL is OSS Japan, and the main branch we need to deploy the application from deploy folder. So this is the folder that I want my Argo CD agent to monitor continuously. And destination is the current cluster in the demo namespace. I want that, and let's create that. So it is creating the application, it is missing, it is syncing, it is synced, and it has already started to deploy the service and the deployment. We can see kubectl get pods -n demo. So demo namespace was not there, it was a fresh cluster, and you can see container creating of the service. And here also the live status, that's what she was mentioning, the live status was evolving. As soon as the application is active, you can see the green heart over there, and we can see here it should be in running state, and you can see it is in running state. So if we go to the service, we can actually see some of the other information what actually it deployed. So you can see the manifest, you can see the service, you can see it is a node port running on the node port this. So let's actually quickly access this application. So we'll copy this and we'll enter the port number from here. Hey, so this is a application which is deployed. Yeah, do not forget to follow us on Twitter. That's why it is mentioned over here. And so this part is already there. That's what she has done. What we are going to, the fancy stuff starts from here. So what we are going to do now is we'll create another application. So we'll go to the home page, we'll create new app, and this time what do we want is we want infra. So we want infrastructure to be provisioned in the same way as we have done the application. So you can see over here inside my Kubernetes in FRA region there is only one cluster which is there right now, no cheating over here. And now I will be giving a project name, again same stuff, automatic sync policy, auto create namespace, repository. Okay, we have to copy this again. So repository URL is the same, and main branch. This time I don't want to monitor the deploy folder, I want to monitor the infra folder, because that is where my infrastructure files will be here. You can, that's where I was saying you can have a different repository itself for your infrastructure. So you can use infra, and destination is this cluster, namespace is default, so we don't have to specify that, and we click create. That's it. So you can see it also synced pretty fast, and you can see it already deployed. So that's again a very fancy thing, like in this you can see the connections. So this particular application that we have defined will create how many resources you can see in the Argo CD UI itself. So you have test Crossplane which is there, which is deployed, and you can see the custom resource that it deployed. So we can actually see kubectl get co Kubernetes, and we will be saying that it is being created. So it says that the cluster is being created with the applications Argo CD and Prometheus operator, and it is the same YAML file that was being that was here, cluster 1. So you can see there you have mentioned applications as Argo CD and Prometheus operator. So this is specific to CO because CO has a marketplace, and you can pick and choose what applications you want to deploy. So you can give this here. You might not be able to give this same configuration for AWS or same configuration for other cloud vendor. And if I go here and refresh this, I should be able to see test Crossplane being created. So now we have actually GitOpsified not only the applications but also the infrastructure, and that's the actual benefit, actual use case that we should be moving forward to, because now what the internal developer team Saloni can do in your team, they can simply come to this repository OSS demo and create a pull request in this particular folder, infra folder, and give the same file, the same custom resource with their requirement. Like let's say a team is there and they want to create a custom resource, they should be able to give the same requirement, and Argo CD will sync that, deploy that custom resource. Control Crossplane will take that and create the Kubernetes cluster or any specified resource that you have defined in the custom resource of your Crossplane. And the drift detection, pretty simple. Like if I try to delete this cluster, so Argo CD, the Crossplane will detect that and it will automatically create this cluster again, because our desired state is stored in Git. As a developer can do a manual error and delete something or do something, but our state is in Git. Everything is verified using the pull request, the reviews, and then only it's merged. So our state is in sync with the Git, and soon you will be able to see that Crossplane will start creating the test Crossplane cluster again once the 30-second, 40-second period, whatever it syncs back in. Also, in this particular file, we have a few minutes and one slide to be covered. So if we change anything in the code, that should automatically be deployed. That's what like GitOps is. Like if we just do anything, like add more exclamation marks, just push that to the main branch, and we should be able to go back and see that there is a GitHub Actions that is triggered. So we can see the details. It will go through the complete workflow of the workflow YAML file that I showed you, building the code, pushing it to the repository, and changing the deployment hello.yaml file, because Argo CD is only watching the deploy folder. It doesn't watch anything else for the application. So it will do that. Meanwhile, it is doing it. What we'll do is we have one more slide. So Saloni, how did you like this particular solution for your use case? Will it help you?
Of course, Sayam, thanks for the great demo. Surely it will help my team. So what to do next? Have an infrastructure and applications repository, have Crossplane deployed with composition-based different cloud vendors, developers to use minimal config to create and push infra specifications, connect clusters to Argo CD. After that, have applications set to deploy preset of apps, get easy usable environments, DR setup, production setup in a true GitOps way.
So these are some of the advanced things. Obviously, after this you don't have to stop. You actually have to use compositions to go multi-cluster. You actually have to use application set so that you can deploy same application to all the hundreds of clusters that you connect to your Argo CD, so that you can create a pre-configured set of cluster with applications for new teams. You can define policies, you can define your standard application set, whatever is there to be installed over there. So I think that's what we had for this particular session and demo. I hope the cluster is getting started to create, and I also hope Argo CD will, this will deploy a new application soon. No. So you can see test Crossplane was starting, started to create again the drift detection thing. So yeah, I hope it was useful in terms of how to GitOpsify your applications and infrastructure using Argo CD and Crossplane. So thank you so much. We are here for questions, if any. And I think we only have 1 minute. But we'll be here around, so if you want to understand anything, the demo repository, the slides are already there. I'll put the link to the demo repository in the slides so that you can go and do this demo yourself. If you sign up for Civo, you get $250 credit as well, just the standard pitch over there. Yeah, I think that's pretty much it. Thank you so much for tuning in.